Now I will talk on the binary trees. In the binary tree, we have a node and we have a integer item, so to store the information in the node, and then each node has a pointer to the left child and to the right child. Okay, um, and also we have a new node. New node takes a parameter integer and it has a pointer, okay, node, and allocate memory and put the item to the item of this node and make the left and right null and then return the address location of the node. So a pointer to the node, so it returns the address location of this node. So here let's write a method to insert an item into the tree. And so here uh, we need to make this, so we will insert it, so and then a new node will be created. We need to know where it is inserted, so we need to get the address back. And let me say insert into the tree, okay, and then the first parameter would be the um, a pointer to the node, which is the root. Okay, so we start from the root and then we insert at the leaf level. So okay, so I say a node pointer, and let me name this um, node. Okay, and then the second one would be just the item I would like to insert. Let me name this okay, so let's say info. Okay, and here um, so it is possible that the node might be null. Okay, so which means consider an empty tree. In that case, the node points to null, which is there is no node in the tree. Okay, so we say if okay if this node is null, okay, then okay, so we allocate memory, so new node, okay, and so that would be whatever the parameter is, info. Okay, so this method returns the address location. As you see here, it allocates the memory and it returns the address location. And we said we want to get that, we want to get the address back. So whatever this returns, I simply return it. Okay, so if this is the case, if it is not null, then we need to find a proper place for this item and insert it. So I will talk about the binary search trees later, but just to keep things simple, I don't want to confuse you a lot in the first video. So let's ignore the left child, and let's say I will go to the right child, uh, and if the right child is not null, just keep going all the way to the all the way until we find a null right child, and then we just create a new node and make the right child point to the new node. Okay, so here I say if, so there is two cases, the right child may be null or it may not be null. Okay, so first of all let's say uh, okay, so let's say it is null. Okay, node and right child is null. Okay, in that case we need to allocate memory, so we need to create a new node. So let's say new node. Okay, the parameter is info. Okay, so this returns the uh, this returns the address location, and then uh, I should just assign it to the right child of this node. sorry. Okay, right. Okay, equals, and then I need to assign it to the as a right, and also I need to return this new address location, which is return. Okay, node right. Okay, so this is if the right is null. But what if right is not null? I should just keep going all the way until I reach to the leaf level, which means the right child is null. Okay, so else, okay, else, which means there is a right child. In that case, I need to make a recursive call, and I say insert, okay, insert, and so this is not, but this will be the right child of the node. Okay, so here I say node and right child, and this will be just info. Okay, so we insert that, but also as you see, this returns that. Okay, so this returns the address location, and here whatever it returns, I will just return it. Okay, otherwise the program will not compile. It says no, you need to return something, and here I just return it. Okay, so we return that. What else? Okay, so now let's see what it does. So here I say um, okay, so insert node. Okay, so this one, actually we need to start from somewhere. So here let me have a pointer to a root. Okay, root, um, and then let me make the root null initially. Okay, so now root is null, which means that the tree is empty. Okay, so first, so here I say root. Okay, and then let's insert 10. Okay, so this returns, but uh, when we come back to here, so there is two ways actually. One way is pass this by reference. So instead of passing to root, I may pass the address location of the root. Okay, so this is one way. The other way is, as you see, we just return the address location. Um, so here we need to update the root. Okay, we say root equals to whatever is returned from here. Okay, and now let's see what it does. Okay, it ran successfully. However, we need to know what we inserted. And here, let's write a method, void method. Okay, let me just do this. Okay, okay, let's write a method, so which is we can make it void, and let me say print tree. Okay, and then the parameter is a pointer to a node, so we need to know where to start. Okay, so here one way would be it might be null. Okay, so if it is null, okay, if node is null, do nothing, just terminate the program. So there is a recursion here. Otherwise, uh, if the node is not null, let's display it right away. Okay, so here I say printf, and then percent %d, because info is integer. Okay, and then so we are displaying the item of the node. Item of the node. Okay, and then um, okay. So if it is not after displaying that, we need to go to the right child all the way until we reach to the leaf level. So here I say if so we need to check if the right child is null. So here node right. Okay, if it is not null. Okay, if it is not null, then we say print tree. Print tree, and the parameter is right child of the node. Okay, right. Okay, now let's display that. So we have root. Okay, and then print tree, and the parameter is root. Okay, now let's run the program to see what happens. Okay, it displayed 10, so that is good. Now let's insert one more item. So here insert um, root. Okay, and let's insert 8. Actually, in this case, we don't have to return. So this return, but we don't have to update the root because we need the root for the first insert. For the second one, we don't really have to assign it. Okay, so now let's see what happens. Okay, it worked. 10, 8. Okay, so this works. I hope this is clear. Have a nice day.